Till now, we completed 5 problems in the exercise number 1.3. In this class, we are going to do about finding inverse of a function. Whatever the coming 5 problems are there, from the coming 5 problems, one 5-mark question 100% guarantee in final examination. So these are not very easy, but if you are good in one function, onto function, then you can do these problems very easily. Let's see what they are asking in this question. Show that the function from closed interval minus 1 comma 1 to r. The function is given like from closed interval minus 1 comma 1 to r, and the function is defined as f of x equal to x divided by x plus 2. They given that f of x is x divided by x plus 2. We need to show that this function is 1 1. That is the first point. First thing, we need to show that this function is 1 1. Okay. Second thing, find the inverse of the function. For the same question only, we need to find inverse of this function, and that function range changed here. You see this function here. What is the range? What is the codomain here? Codomain is all real numbers. Here what is the codomain? Codomain is range of f. Please try to understand what is the given information. First point, function is from here to here. We need to show that this function is 1 1. Second point, find the inverse of the function. For what function? Here you observe the mapping little bit changes there. Here codomain is real numbers. Here codomain is range of f. Slowly we will do. First thing, I want to prove that this function is 1 1 function. Okay, I'll write the given information. See here what they given. F is from closed interval minus 1 comma 1 to r. That is they given. And you see here f of x is given as x divided by x plus 2. F of x is given as x divided by x plus 2. What to show? We need to show that this function is 1 1 function. For that, first what I'll do, I'll consider f of x1 equal to f of x2. You consider f of x1 equal to f of x2. Okay, what is f of x1? Look here, f of x1. F of x is what? X divided by x plus 2. Now, what is f of x1? x1 divided by x plus 2. You can observe here. As they given f of x is x divided by x plus 2, f of x1 is x1 divided by x1 plus 2. What is f of x2? As f of x is x divided by x plus 2, what is f of x2? x2 divided by x2 plus 2. In this function, wherever x is there you write x plus 2. So here, as I considered first, I taken f of x1 equal to f of x2. Now I'll simplify this further. You just cross multiply. What happens? x1 into x2 plus 2, multiply these two, equal to x2 into x1 plus 2. Cross multiply. Okay. Now further I'll multiply x1 into x2 plus x1 into 2. That is 2x1. Now multiply these two. x2 into x1 is x1 x2 plus 2x2. I hope you are understanding. Just normal multiplication only. You see this x1 x2 x1 x2 will get cancelled. What is remaining? 2x1 equal to 2x2. Here 2 also will get cancelled. Then what you will get? You will get x1 equal to x2. By this time you already know we done in exercise number 1.2 also how to check the given function is 1 1 function onto function. What happened here? I considered f of x1 equal to f of x2 and I got that x1 equal to x2. From this we can say that the given function is 1 1 function. What they are asking in the question? They are asking to show that this function is 1 1 function, and I proved that this function is 1 1 function. Okay, and one more important thing here. Find the inverse of the function, but you can see this codomain is changed. Okay, why the codomain is changed? In last problem, we learned that, fifth problem, we learned that inverse of a function exists only when the function is bisective. Inverse of the function exists only when the function is bisective. Bisective means the function which is both 1 1 and onto. Here, this is already 1 1. To check onto, they changed this codomain. Here, small shortcut is there. Not shortcut, actually one important point is there. When codomain is same as range, then the given function will be onto. When codomain is same as range, then the given function is onto. No need to check anything. You see here, this is codomain. In place of codomain, they directly written this codomain is nothing but range of f. That means they are given that codomain equal to range. When codomain equal to range, it tells you that the given function is onto function. As the function is 1 function and as the function is onto function, we can say that this function is function f. F is bisective, right? This function, you see, this is the function. This is bisective. When it is bisective, inverse exists. When the function is bisective, then inverse exists. So you see here, whatever the step I written, this is very important. This holds good only when the function is bisective. This holds good only when the function is bisective. See here, f of x equal to y if and only if x equal to f inverse of y. This holds good only when function is bisective. So what I'll do, how to find the inverse? In this, two things are there. First thing is we need to show 1 function. For that I take an f of x1 equal to f of x2. I proved x1 equal to x2. Second one is how to find the inverse. To find the inverse, the function must be bisective. So I checked whether it is bisective or not. It is bisective. Once it is bisective, then to find the inverse, you follow this method. You look here, f of x equal to y implies x equal to f inverse of y. This works only when the function is bisective. So see here, f inverse of y is what? Inverse of f is what? Inverse of f is x only. How to find this x? I'll tell you now. To find the inverse, first you take f of x equal to y. F of x equal to y. Look here, f of x equal to y. First you take f of x equal to y. In the question they given what is f of x. What is f of x? They given f of x equal to x divided by x plus 2. Okay, x divided by x plus 2 equal to y. Now what is my intention? I want to find f inverse. As the function is bisective, what is f inverse of y? F inverse of y is nothing but x. Now what I'll do, I'll simplify this little bit and I'll write x in terms of y. I'll simplify this little bit and I'll write x in terms of y. You just cross multiply. Okay, now you take xy to the left hand side, x minus xy equal to 2y. Take x common. If you take x common, x into 1 minus y equal to 2y. From this, what is x? Look here. What is x? X equal to 2y divided by 1 minus y. What is x? Look here. What is x? X equal to f inverse of y. F inverse of y. Okay. So what I am trying to say, first you take f of x equal to y and you write x in terms of y. As it is bisective, what is x? X is nothing but f inverse of y. So f inverse of y is 2y divided by 1 minus y. As you know f inverse of y, you can write f inverse of x also. What is f inverse of x? 2x divided by 1 minus x. I hope you are understanding. Right? Now, next question. See this question. See, I am saying again and again, there are total 6 problems are there. From these 6 problems, one 5-mark question, 100% guarantee. Just one problem is completed. This is the second problem. You see what they are asking. Consider f is from R to R given by f of x equal to 4x plus 3. This is important one. F of x equal to 4x plus 3 and the function is from all real numbers to real numbers. They are asking, show that f is invertible and find the inverse of the function. Find the inverse of the function. Okay, two things are there. They are asking you to show that it is invertible and find inverse of f. And in fifth problem we discussed function is invertible only when it is bisective. First I'll write the given information. They given f is from real numbers to real numbers and the function is given as f of x equal to 4x plus 3. To prove the function is invertible, to show the function is invertible, I need to show that it is bisective. To show the function is bisective function, I need to show it is 1 function and onto function. So first I'll check whether the function is 1 function or not. How to check the function is 1 function or not? First, in exercise number 1.2 also we learned how to check the given function is 1 function or not. First I take an f of x1 equal to f of x2. Here I want to tell you one shortcut which will be useful in JEE problems. When function is defined from real numbers to real numbers and f of x is of the form ax plus b. F of x is of the form ax plus b. Then that function is bisective function. So no confusion. When the function is of the form ax plus b and f is from real numbers to real numbers, then that function is bisective function. However, here I am going to prove all those things. To prove the function is 1 function, first I take an f of x1 equal to f of x2. What is f of x1? In this, in place of x, you write x1. What is f of x1? F of x1 is 4x1 plus 3. What is f of x2? F of x2 is 4x2 plus 3. Okay, now you do little bit of simplification. You see, this 3 will get cancelled. What is remaining? 4x1 equal to 4x2. From that, we can write that x1 equal to x2. So here, what the point? When f of x1 equal to f of x2 implies x1 equal to x2. I taken this information and I got this. When I am able to say these things, what I can say? I can say that the given function is 1 function. So what is my intention? I want to show that this function is invertible. To prove the function is invertible, I need to check 1 function and onto function. I checked 1 function, this function is 1 function. Now I will check about onto function. See, onto function. Here few tips I will tell, please listen. First thing, you write like this, like f of x equal to y. What is f of x? In the question given that f of x equal to 4x plus 3. You observe in this margin whatever I am writing. First you take f of x equal to y. F of x is 4x plus 3, that is given in the question. Now write x in terms of y. Write x in terms of y. Listen this carefully. Now what to check? You see, what is onto function definition? For every element in codomain set, there exists at least one preimage. Here you see, when y is any real number, this is because this function is from R to R. Na? They given in the question this function is from R to R. So I am taking one element in this codomain, y in R. There exists x. X you should take like this. How you got from this? First you write f of x equal to y, x in terms of y. Whatever you got here, look here, whatever you got here, that is x. There exists x. What you need to check? Whenever y is a real number, this x is a real number or not, you need to check. Whenever y is a real number, this x is a real number or not. Here for all y is a real number, x is a real number or not. You take any one real number, 1 by 2. 1 by 2 minus 3 divided by 4 is a real number or not. Like that, for every y, x is real number or not, you need to check. Okay, so I taken x like this. Now you know, in exercise number 1.2 how we proved the function is onto function. First we will take y in codomain set, corresponding to that we will take x in domain set, and we will find this x value by using this method such that f of x equal to y as per the definition. Okay, so now as I considered y and I am checking that I found that x, now I need to show that f of x equal to y. Okay, f of x. Here what is x? Look here, in place of x I am writing this expression. Please try to understand. F of x is what? X is what? Y minus 3 divided by 4. So in place of x I will write y minus 3 divided by 4. So I need to calculate f of y minus 3 divided by 4. You see here f of x is given as 4x plus 3. Na? In place of x, here in place of x, y minus 3 divided by 4 is there. So in this function, wherever x is there, I will write y minus 3 divided by 4. See here, 4 into y minus 3. In place of x, I written this information. In place of x, y minus 3 divided by 4 plus 3. I hope you are understanding. To calculate this, in this function, wherever x is there, I written y minus 3 divided by 4. Now 4 will get cancelled. Now what is remaining? Y minus 3 plus 3. Minus 3 plus 3 also will get cancelled. You will get y. This tells you that for every y belongs to R, there exists x belongs to R such that f of x equal to y. You observe this one. This is important one. If I show this, then it tells you that this given function is onto function. So as I shown this statement, I can say that the given function is onto function. Okay. So what happened here? Here you see this is equation 1. I proved that this function is 1 function. You see here equation 2. I proved that this is onto function. From 1 and 2, I can say that this function is bisective. When the function is bisective, then only you can write this. What is this? F of x equal to y, if and only if x equal to f of y. This you can write only when the function is bisective. I hope you are understanding, right? This you can write only when the function is bisective, right? Okay, now they are asking to find the inverse of the function. Very simple. To find the inverse of the function, see, f inverse of y is what? F inverse of y is nothing but x. In last problem also we followed the same method. First I'll take f of x equal to y, and then I'll write x in terms of y. You see here, what is f of x? In the question they given f of x is 4x plus 3. 4x plus 3 equal to y. From this, you can write what is x. What is x? Take 3 to the right hand side, y minus 3 divided by 4. You can understand this, x equal to y minus 3 divided by 4. Okay, what is x? X is f inverse of y. Look here, what is x? F inverse of y. F inverse of y is what? Y minus 3 divided by 4. So, I shown that, see here, first thing, as it is bisective function, you please write one more step here. What is the step? F is invertible. As it is bisective, f is invertible. I proved that the function, I showed that the function is invertible and I calculated its inverse. I hope you understand these problems. Finding inverse of a function is very important 5-mark question in second PUC. Please go through these 2 questions. In the coming class, I'll do another 2 problems. I hope you understand this class. Thanks for watching this video. Have a great day. Bye-bye.